Your teacher tasks you to form a group consisting of 4 members in your class composed of 44 students. And it's up to you to pick your group mates. You chose Jay, Keiru, and Kyle. Does it make any difference if you chose Keiru, Kyle, and Jay? Of course not, because they are the same people. Each selection that you could possibly make is called combination. However, if you chose Kyle, Keiru, and Kevin, a different combination is addressed. My name is Jay Lawrence Season, and you can call me Jay.
And I am Kyle Gabriel, and you can call me as simple as Kyle.
And we are from the community of Marikina Science High School. We are here to help you learn more about combinations. First, I will define combination. Combination is a collection of objects where the order doesn't matter. Combinations are easygoing, as I mentioned earlier. Order doesn't matter. You can mix it up and it looks the same. To further understand this concept, let us revisit the situation that we gave you earlier. If you were to choose 3 students as your groupmates out of 44 students in your class, you can pick any of your classmates, but choosing Jay, Keiru, and Kyle is the same as picking Keiru, Kyle, and Jay because they are the same people. But for example, you did not choose them. How many selections do you think you can make out of 44 students picking just 3 from them? Let me show you the numerical expression of the given situation.
Let n be the total number of students and r be the number of students you will choose. Substituting this, you will get n is equal to 44 and r is equal to 3. In order to find the number of selections you can make, you can use the formula C is equal to n factorial over the quantity of n minus r factorial times r factorial. Substituting the given values to the formula, you will get 44 factorial over the quantity of 44 minus 3 factorial times 3 factorial. And simplifying this equation, you will get 44 factorial over 41 factorial times 3 factorial, leading to the final answer, 13,244 combinations. In this situation, repetition is not allowed because you cannot choose a classmate 3 times. For example, you cannot choose Keiru again if you already pick him as your groupmate because there is only one Keiru in your classroom. But there is a case where repetition is allowed. For example, you were at a sushi bar that offers 10 different types of sushi, from which you can choose 4. Suppose the first type of sushi you choose is salmon. As the menu allows you to have 4 pieces of sushi, your second, third, and fourth choices could also be salmon. In this scenario, repetition is allowed. Again, let us have its numerical expression. Let n be the total number of sushi and r be the number of sushi you can have. Substituting this, you will get n is equal to 10 and r is equal to 4. In case you were asked how many selections you can form in the given situation where repetition is allowed, you can use the formula C is equal to the quantity of n plus r minus 1 factorial over r factorial times the quantity of n minus 1 factorial. Substituting the given values to the formula, you will get the quantity of 10 plus 4 minus 1 factorial over 4 factorial times the quantity of 10 minus 1 factorial. And simplifying this equation, we will get 13 factorial over 4 factorial times r factorial, leading to the final answer, 715 combinations. And tada! We're done!
Thank you for listening. We hope that you learned something from this simple podcast.
Oops! But before we end this, I would just like to give you a friendly reminder. Don't get confused with permutations and combinations. Because again, in combinations, order doesn't matter. Bye-bye!